Hello, good evening. This is Mugenyi Alan, offering computer science, year one, first semester. I'm here to talk of the development of computers. I talk of computer generations and then talk of evolution of the Intel x86 architecture and ARM architecture. As per my screen, uh, I'm giving the outline with generations. I'm going to talk of the first, second, third, fourth, and fifth generation. Then coming to the processors, I'll talk of the architecture of Intel x86, then ARM architecture. Proceeding, we have an introduction where we're talking of computers. A computer being an electronic device that can be able to input, output, and it can be able to input, process, and output data or store data as required by the user. We see in the beginning we had computers such as Abacus, then coming on we see Charles Babbage bringing on the analytical engine, being called the father of computers, having Abba Lovelace who wrote logarithms for Babbage's machine and being called the first programmer. We see machines coming up and all this, the development in computing, given hardware, software, and everything is what we call computer generations. When you look at the years, I've made a slide indicating the years, seeing first generation, second, third, and fourth, up to fifth, the present generation, because our fifth generation runs from 1985 up to the present. To talk of uh, this is a pictorial presentation of the generations. We see in the first gen, computers were very large as we're going to explain. Then first generation, to talk of the first generation, this marked the start of electronic digital computing. Vacuum tubes were being used. It was the main invention in the first generation. Then the computers here were very large, they were very slow, and they required a lot of power. They also required very large space. They were unreliable. They were very expensive uh, because to give an overview of that, take an example of the ENIAC. ENIAC is the electronic numeric integrator and calculator. Then the UNIVAC, which is the universal automatic computer. Uh, Back here on the last slide, we see in the first generation, you can having a look at this first generation, the first diagram here. We see very many wires, we see very many components and taking up a large space. That was the first generation. Mainly things were more complex and very hard to deal with. To talk of ENIAC specifically, ENIAC was used in the Second World War, to count bullets, and it was called a numeric because it was more of adding up and counting. To talk of second generation, in the second generation, it was just an advancement of the first generation, where we had the transistors replacing the vacuum tubes. We have computers became smaller, faster, and more reliable compared to the first generation computers. Then magnetic cores being used for memory, magnetic ROMs for data storage and program storage. Then there we look at assembly languages and operating systems starting to emerge. Earlier on, assembly language is a language in machine code, or they are very low level languages. For example, languages that can be easily understood by the computer or the machine in terms of zeros and ones. So we're seeing in the second generation, that's why they started to evolve. Looking at the third generation, we see ICs or the integrated circuits, which was the main innovation in this era. We see increasing processing speed compared to the first and second generation. Also, the computers became more powerful and smaller compared to the first generation computers. Earlier on, the ENIAC, which is the main example in the first generation, it was a very large computer taking a lot of space, but coming to the third generation and with further generations, the computers were being reduced in size. In the third generation, we see an issue of time sharing whereby multiple users could access a single computer simultaneously. Then also introduction of peripheral devices. Computers were now being designed so that they could support peripheral devices. For example, the keyboards, the printers, which can be just attached to the system unit. Earlier on, computers were built together and made like a complex thing. But as we come to the further generations, we see that now portability is coming into play. You can even have a device being connected to the system unit, which can improve versatility. Also, in the third generation, we look at increased user friendliness and functionality, whereby computers could easily be used here in this generation. Looking at forward view, we look at the fourth generation. In the fourth generation, we look at microprocessors being the main invention. Uh, Microprocessors is one of the standards of modern computers. I will look at very large scale integration, which was being introduced, and this very large scale integration was being used to combine transistors to form an integrated circuit. And as you can see, microprocessors they can be classified as integrated circuits because it is after a combination of very many transistors to get an IC. In the fourth generation, the computers became smaller with increasing processing power. Compared to the first generation, these computers in fourth generation were faster and they were very smaller, which increased portability. There was introduction of personal computers, for example, the IBM PC, and then early computers. The graphical user interface, such as Windows, was introduced by Microsoft, which made computing very easy. Development of high-level languages, for example, C++, C, an example of Python. We look at all those languages that can be easily understood by the human beings. So these languages is programming and coding, and also we see introduction of software applications on mobile devices. The birth of the internet also occurred in this generation, where the internet started to become very very powerful and very known. Then global communication and data sharing was also key in this generation. To look furthermore, we look at very large scale integration, which is a process of creating an integrated circuit by combining a number of transistors. A transistor is just a simple device that can regulate current and also it can regulate voltage. As far as the physics is concerned, it was an invention of the second generation, but in the fourth generation where VLSI was introduced, we see it worked on the producing of the microprocessors because microprocessors were introduced in the fourth generation. To go forward, we can look at fifth generation, whereby we see artificial intelligence coming up and robotics. Artificial intelligence, it is intelligence which is artificial, the same way you can hear it, giving machines human-like capabilities. We look at natural learning processes in this situation where machines can be taught, they can learn how to speak like human beings, they can be fed in with information and data so that they can use it appropriately to communicate to the human beings too. An example you can take is Google Assistant. Uh, Given you speak to it, it can speak to you back in a human-like form and language, which is a new development in the fifth generation. You can look at very many AIs evolving. For example, look at ChatGPT, look at Microsoft Bing, which is embedded by ChatGPT. Look at very many assistants such as Alexa. Look at Cortana on Windows, Bixby. Then in the fifth generation, you also see massive data storage and retrieval speeds where data was now being stored in terabytes compared to the first generations where data was being stored in MBs, GBs, now data is stored in TBs. We see introduction of research on quantum computing and cloud computing. Cloud computing is use of online resources and most of the times accessing resources online without too much intervention of the service provider. For example, maybe someone working online, maybe accessing Microsoft 365 online. If you cannot access it on the computer, you can contact the service provider in another country to access various resources. Talk of storing cloud storage where you can store your photos, your documents, and everything on cloud. Maybe Google storage, maybe Google Photos. Look at iCloud for iPhone. Then the fifth generation also see human-machine collaboration becoming key, whereby humans and computers were becoming inseparable. Uh, to continue, this is a brief example of a fifth generation where we see robotics. Robots were now taking over, being created in various countries and various industries. And then to talk of the next thing, talk of the Intel x86 architecture and the ARM architecture. Intel x86 architecture is the type of it is a complex instruction set architecture. Mainly, it works in desktops and servers and workstations. And then ARM architecture is basically for a reduced instruction set computing. Maybe it works generally in smartphones and small devices, but stronger devices. Intel x86 architecture uh, has evolved over very many years, and some of the notable families can be the 8086, the 286, the 286, then the 486. Look at Pentium, Pentium Pro, Pentium 1, Pentium 2, Pentium 3, Pentium. We look at the Intel Core Solo, the Intel Core Duo, then we go to Intel Series 01, then and many other types. We go to Core 2, then we have Core i5, Core i3, Core i7, Core i9, their respective capacities, as we are going to discuss in the evolution of Intel x86 architecture. And one of the main benefits of Intel x86 is the backward compatibility of software in other Intel processors. Evolution of Intel x86, we're looking at in 1978, where the first processor was introduced, which is 8086, which marked the beginning of the Intel x86 architecture. It was a 16-bit processing. Then it can be noted being used in the original IBM PC in 1978, having the 1982 where we see the 286. This can also be referred to as the 286 processor, which was a 16 to 32-bit hybrid mode, enhancing multitasking capabilities. We have the 83 and 86, which was 32-bit. It had a storage of around 4 MBs. Uh, it set a stage for modern PCs. Look at the 84, 86. It was also referred to as the 486 processor. It was also a 32-bit processor, which was being used in personal computers and at workstations. It had a storage of 4 GB. Looking at Pentium coming up in 1993, which was also like a family, having Pentium followed by Pentium Pro, Pentium 1, Pentium 2. Pentium came in 1993, then followed by Pentium Pro in 1995, which introduced a complex microarchitecture to improve performance. Pentium 2 and Pentium 3 in 1997 and 1999 continued the use of the P6 microarchitecture, uh, having the Pentium 4 with a net bus architecture, which improved on the clock speeds. We see Pentium M in 2003, followed by Core 2 Duo, then Core i7, Core i5, i3, i9, until the further generations evolutions. Core i9 was introduced in 2017 with Turbo Boost technology. This technology was to enable the processor to step up to a speed that is required when the user is working. For example, people who deal with video games, editing, among others, video editing, which require execution of many tasks at a single time. So This was to increase processor speed, hence introduction of turbo boost technology, which came with Core i9. Core i5 was brought in 2009. It had 774 million transistors. In the end of the Intel x86 as of the current, we have Evo, we have Kaby Lake, we have Alder Lake, we have Graphics Arc, among others, uh, which is part of the Intel x86 architecture. Coming to ARM architecture, ARM falls under the reduced instruction set architecture. Uh, ARM in full is advanced risk machine, where risk is reduced instruction set. ARM, despite Intel x86 being seen in desktops, workstations, among others, ARM architecture is seen in embedded systems. We see ARM architecture in tablets and Internet of Things devices. It is highly scalable, and meaning it has various levels of complexity and can perform different. It can issue out different needs of the users. Going to the evolution of the ARM architecture, in 1985, we see the first RISC machine, which was produced by Acon Computers, and it was called the Acon RISC machine. Looking at it, 1986, 1 year after, we see ARM1. Then 3 years after, in 1989, we see ARM2 and ARM3, which was introduced with a memory management unit as a main characteristic. Then look at ARM6 in 1991 with 26-bit addressing. 1990s, we have ARM7, which found success in embedded systems, mobile devices. Uh, then look at ARM9 with ARM V5 architecture with better performance and support for more advanced operating systems. We look at ARM10 in 2000, ARM11 coming in 2002 with ARM V6 instruction set, which enabled Java execution. Having Next, we have Cortex R and Cortex M series, one in 2004 and the other in 2006 respectively. R came faster in 2004, then the M series came in 2006. Uh, Next, we have the ARM S series. For example, ARM A5, ARM A7, ARM A8 series, ARM A12 series, among others. This targeted an increase in performance, hence powering smartphones and tablets. Then we look at ARM Cortex A9 coming up in around 2009 for further performance improvement. And then lastly, we see ARM Cortex series in 2012, among others, having ARM A7, ARM A7 III series, Cortex A7 5 series. These improved efficiency. And from 2019, there was development of these series in favor of AI and 5G technology, which is the trend of the modern world. In conclusion, Intel x86 is mainly used in desktops, workstations, and servers, whereas the ARM architecture is mainly used in in mobile devices and embedded systems. Uh, this all has led to further modern computing being innovative. Thank you. Remain Alan.